This short demo video provides an overview of the new multiple blocking key feature in clearMDM Winter 25. The clearMDM matching algorithm has three phases. The first phase groups records by a coarse-grained blocking key. Records with a common key are then subject to key and deterministic rules, which efficiently match or eliminate records based on significant identifiers. And then finally, fine-grained fuzzy rules are applied, which calculate field-by-field, record-level match scores to be evaluated against the configured match threshold for the Salesforce object. Historically, the selected key construct for the blocking key has required the use of fields with dense population across the record set. For example, the person's first name and last name, or for companies, the company name and country. Where different keys are required for different types of records in the same Salesforce object, it is possible to have a different MDM configuration per record type. However, this approach can be undesirable, where the introduction of new record types would be disruptive, and also records remain limited to a single key. With clearMDM Winter 25, it's now possible to have multiple blocking keys, up to 3 keys per record in fact. This new approach allows records to be matched on any populated key. For example, records from a web form with no address inputs could use a key based on name and email, whereas ERP system integration data could also use a key based on name and address, and those records would match based on common factors. So if you start the demo here in the settings UI, I can see now that for our person account target object, we have the primary blocking key structure, this time based on last name and the other phone field. But now I also have secondary blocking key settings. I can define a blocking key 2, in this case with last name and phone, and also a blocking key 3. In this case also we have last name and email. So if you look at some records here in a list view, you can start to see for these person accounts there, they have multiple blocking key values based upon those particular inputs. You take a case and see how this actually looks and works in practice. We have Henry Rogers here. You can see that the first blocking key, the primary blocking key, is incomplete. There is no other phone value. Second blocking key is complete, as is blocking key 3. There is a second instance here of Henry Rogers, and I can see that there is a similar picture here in terms of the population. If we look at the blocking key 2 and 3 specifically, I've got a 771, and then we have the blocking key 3 value. If I go back to the first record, I can see there that whilst they both have a blocking key 2, it's different, but they do have a common blocking key 3. So now if I actually send this record to be cleansed, matched and merged, what should happen here is the system will attempt with the first populated blocking key. It will find that there is no match because they are not common values, but it will proceed to use the third key. Let me refresh the record and just double check the matching merging is complete, and that is the case. One of the records is the merge master. One of the records is the second record, I should say, if I refresh here, is the merge source record. But if I quick look at the blocking key record, you can see that the blocking key process request, this is the queue mechanism that supports the real-time process, was actually generated based on blocking key 2, but was set by the cleanse process to be enabled for multiple blocking keys. And what that means in practice is it will work its way, it will loop through the populated blocking keys until it finds a match. And in this case, as we saw, the match actually was possible, and it was enabled through the commonality of blocking key 3. The second way to look at this, if we jump to a third and final record here, I can see now if I go to the find matches function. This is now dynamically working out where we have populated blocking keys. And when I'm running the matching process, you can see first of all, if I use blocking key 2, there are no matches. If I switch to blocking key 3, then matches are found using that particular key. So in this case, we're specifically and explicitly defining, okay, which key do I want to use to find my matches, which is fine with a piece of UI like we see on screen. However, the automated processes, the API operations, the platform actions that are used in Lightning Flow, the background process that we saw with the blocking key process, and also the batch jobs themselves, they are all able to understand and dynamically work sequentially through the populated keys up until the point matches are found. And if you think about how this would work in a sort of real sense, if we have groups that are identified based on the primary key, matches can be introduced and added to those groups using the secondary keys, either blocking key 2 or blocking key 3, and then changes to those records over time would synchronize in the normal way. Okay, that ends the demo. Thank you so much for watching.